Hi guys, BuildZoid here, and today we're going to be doing a BIOS walkthrough for the MSI X570 Godlike. So this should be relatively similar to what you'd see on a lot of other MSI X570 motherboards, but of course the Godlike is the highest end board that MSI makes, so it kind of has more settings than what you'll get on a lot of other motherboards. Anyway, as you can clearly see, the CMOS has been cleared, so the BIOS is wiped. This is what it would look like if you've got a fresh board. So let's go in. Wait. It's F1 to... Yeah, there we go. So first things first, let's get out of easy mode into advanced mode, because advanced mode is where all the good stuff is, and easy mode is... Well, I actually don't know what's in easy mode, because I never use it. Anyway, the next useful thing to remember is if you hit F1, it gives you this list of shortcuts for various functions in the BIOS. So, yeah, that's useful to know. Anyway, with that out of the way, I guess let's address the top bar first. So first things first, we have this stupid game boost thing, and it is stupid. So, for example, if you set it to 11... yeah, it'll try to overclock your CPU to 4.45 gigahertz, which I can pretty much guarantee will not work. So, right off the bat, that right there, useless. If we set it to 10, it tries to overclock your CPU to 4.4, which will still probably not work. Like, top Ryzen 3rd gen chips will be maybe 4.3 gigahertz for like actual true stability. Okay, by which I mean you can actually pass AVX workloads, not just like Cinebench R20. Cinebench R20 is actually very light. It's not really any hotter than R15. It just kind of runs some AVX instructions as well. So, you know, it's like, yeah, it's AVX accelerated, but it's nothing like an application that really takes advantage of AVX to its fullest extent. And, you know, the best simulation for that is, in my opinion, Prime 95, because you're really not going to find anything that's hotter than that. And you may find things that get basically as hot, like, say, certain video encoders and that kind of thing. So, you know, that's why I like to use Prime 95 as a stability benchmark, because if you pass Prime 95, you're probably not going to run into anything else, like anything that you won't pass. Anyway, if we set this to 8... 4.35 gigahertz. Like, the thing is, it basically just tweaks your CPU ratio a little bit. Like, I really see absolutely no reason to use this. Even if you set it all the way down to 2, it'll actually be setting your CPU to, you know, 4.2 gigahertz, which actually for my chip is not stable. Like, my chip can't do 4.2 at reasonable voltages anyway, so... Yeah, that's just... As far as I'm concerned, you may as well ignore that the game boost functionality exists. I'm not even really sure why MSI still has this functionality on their boards. I don't remember... Well, no, I do know why, but... Well, I don't get why they bother. Anyway, next to that, you can enable your... yes, there. So next to that, we have an XMP on-off button. This basically has the same function as if you were in the OC tab and just enabled your XMP like a normal person. You know, because... damn it. I hate the top bar. Anyway, next to that, you have some boot priority settings right here. But again, you have another way to set that in the motherboard settings tab. This thing right here with the redundant name, right? Motherboard settings. So, yeah, overclocking settings. Anyway, so, you know, you can set your boot order from there or from the top bar if you want to. Then, of course, you can go back to easy mode. What's this? Oh, there's a search function. How nice. I've not tested that out. You can change your language up here. And then I assume that's an exit button, right? Yes, that's an exit button. So we're not going to hit that. I don't normally use the top bar of this BIOS at all. So yeah, you know, special edition of BuildZoid doesn't know what all of the fancy graphical UI stuff is supposed to do. So, you know, I do have a B450 MSI board that I do have updated to the latest, like, well, I don't know if it's the latest anymore, but I did update it to the Ryzen 3rd gen BIOS, and it's not a max board, so obviously it has, like, the stripped down MSI BIOS. I really didn't notice any downgrade. If anything, I think the stripped down BIOS is a little bit easier to, like, a little bit nicer to navigate in some ways. But anyway, so let's get into this. But this is fine actually, because you can entirely ignore the top bar in regular usage as far as I'm concerned. So Anyway, let's go through the overclocking menu. So the first thing, we have here is the OC Explore mode, which we're just going to put into Expert, because basically all this does is it hides or shows some extra options in the overclocking menu. So it really, like, by putting this into Expert, it doesn't actually set anything. It just gives you it gives you access to more settings. And there's really no harm in having access to things that you're not going to actually change, right? If you don't touch them, it won't do anything. So you can leave it in Expert as far as I'm concerned. Next, we have the CPU ratio. You can just punch in values for that, of course. Plus minus works, typing works. Putting A in puts it back on auto. You can set it low, you can set it high. Works as you'd expect. Next, under that, I really need to stop pressing the down arrow. Arrow to the left. Anyway, so next we have the advanced CPU configuration, and this is where you'll find your precision boost overdrive settings. So MSI's gone, I think they're trying to do something similar to Asus, which I thought when Asus was doing this on X470, it was stupid because it didn't, for me, it never worked. Well, here, these work, they don't crash, so that's good, but they also don't really have any difference in between. There's really no advantage to using them, so I don't know why you'd use them. Anyway, so you can disable PBO, you can enable PBO, you can use enhanced mode 1, 2, 3, 4, 1, 2, 3, 4. I did not notice any performance differences between any of the enhanced modes, so yeah. Then there's eco mode. I did not test that because this, it's a freaking desktop CPU. Why would you, I guess somebody might be building a media center, yeah. Why would you use a Ryzen 3rd gen CPU for that? I guess you could use an APU for it, but yeah, so there's a low power mode for your CPU, it's I still don't get why you'd underclock your CPU, but you might want, no, because the thing for me is why would you want to, why would you buy an 8 core with, say, a 65 watt TDP, then slap a 45 watt heatsink on top of that? And we're going to ignore the fact that TDP has no real relation to any physical value at all. It's just a marketing number. But, so you slap your little passive heatsink on it, and then you, disable, you slow down the 8 core into being about as fast as a quad core, just so that you can run it, why didn't you just buy a lower power CPU? I don't get the point. Anyway, if you put this into advanced mode, that gives you access to the actual PBO limits themselves. You can disable the limits. I don't know what that does. I've not tried it. And by don't know what that does, I'm not sure if that means there are no limits or if it means that, I would assume there's no limits if you hit disabled, but I don't know how that would actually work, because as far as I know, you can just set the limits really high. And I do know that, actually, no, it might be no limits. But at least on the one other motherboard, if you set your PBO limits too high, it would bug out the PBO thing. So, not really, it would behave strange, and it wouldn't really give you any benefits. So I wouldn't use disabled anyway. Next, we have motherboard, which is a bunch of preset limits from MSI, and then you can set manual limits, which MSI still has a restriction on these, so you can't really set them to truly ridiculous values. These are, in my opinion, far too reasonable. They are so high that, no CPU is ever actually going to hit them. Even if you had a 3950X, it's not going to pull 490 amps ever. And if your software is reporting that it's pulling 490 amps, your software is misreading the current sensors because that's not physically possible. No, if your CPU is hitting 100 plus, degrees, it might actually, no, your CPU would probably stop working by the time you see 490 amps average current draw. So anyway, yeah, so you can just max out those limits. There's really, the good thing to actually having a limit restriction here is that on a different motherboard, if you punched in a too high value, it would actually cause issues, which I assume is equivalent to having disabled on this board. But I've not checked what disabled does, because that doesn't make sense to me why that would be a thing anyway. So yeah, and if you are doing PBO overclocking, if you just want to get some extra performance out of your Ryzen 3rd gen CPU, the easiest way is to literally just max out all of these limits, then adjust your precision boost overdrive scaler to 5 times, and not touch anything else in the BIOS except maybe your memory settings, because nothing else really does anything. So you know, you have the precision boost overdrive scaler from like 1x to like 1, 2, 3, and 4. Well, there are actual differences between these 4 in terms of the voltages they run. There doesn't really seem to be much performance difference between them, which is kind of strange. It might also vary by motherboard, and yeah, but in my testing, like, there's certainly no harm in just running like 4x, 5x, and between like above 4x to 10x, there's literally no difference. These are all the same thing, and I would honestly just run straight up like I like the number 5, so I'd run 5x, but you can run 4x or whatever. You might find that maybe your cooling system isn't enough for ratios above 1x or 2x, but and the thing is, the CPU will throttle down if it gets too hot anyway, so, you know, just kind of, yeah. Anyway, next we got CPU boost clock overdrive. So this right here is supposed to be restricted to 200 megahertz by AMD spec, but somehow MSI has that settable up to 500 megahertz. Not that it matters, because it doesn't do anything. This is about as useful as the voltage slider on modern NVIDIA cards since Maxwell, as in it does absolutely bloody nothing. So that's great. Well, apparently if you have a 3600, it might actually give you a little bit more boost, but with my 3700X, tweaking that setting right there has no impact on performance. I don't know, it might actually increase the reported frequency, but if it doesn't actually improve the performance, then I couldn't care less that the CPU is reading 6 gigahertz if it's performing like it's at 4, right? Like, that's kind of like, you know, the thing. So performance-wise, this makes absolutely no difference. You can set it to whatever value you want, but well, I guess if you have the 3600, it might actually do something. But I don't have a 3600 to check that with. My 3700X couldn't care less. I've tested it from like, I tested it in, I think I tested 25, 50, 75, 125, 200, 500, always the exact same performance in single core, quad core, 8 core, well, single threaded, 4 thread, 8 thread, 12 thread, doesn't matter how many threads you throw at it, this doesn't do anything. At least not for my chip. It might vary with others. Next, we have platform thermal throttle limit. Hey, do you want to destroy your CPU? There's a great, well, you can set that and remove the heatsink. I would assume that would allow you to hit up to 255 degrees Celsius, at which point the solder actually holding the IHS in place would actually liquefy at around 170-ish. So yeah, by the time, if the CPU actually got all the way to 255 without like shutting down, like, well, no, it might lock up and still keep getting hotter. So that's kind of the thing, is just like, just because it isn't functioning doesn't mean it can't suck up more power. Anyway, that's a great way to potentially blow up a chip. If you feel like doing that, I would honestly recommend you just leave that on auto, because the CPU, like, auto is just the safe value that you get from AMD. And we get SoC current optimization. I actually have no idea what any of these does. I did test with them maxed out, and I do believe I tested with them on auto as well. Didn't really notice any difference. I assume these are more settings that are about as useful as the boost clock override, as in they don't do anything. Then we have CPU core performance boost. This, if you disable this, your CPU stops boosting, which in the case of a 3700X would mean that the CPU would be always stuck at 3.6 gigahertz, because that's the base clock. And if you disable your boost, you're going to be stuck at base clock. So don't turn off your boost, right? Like, if you like having performance, don't turn off your boost. Anyway, next we have CPU CCD control, so you can select how many CCDs are active. I obviously have a 3700X here, so it only has one CCD. If you had a 3900X or a 3950X, you would have two CCDs, but, you know, so you could actually choose, like, I don't know if you could choose which one's active, but you could certainly go from running two CCDs to running just one CCD, whereas I obviously don't have that choice because I only have one in the first place, so it's not like I can, you know, turn off all of the cores in my CPU. Anyway, next we have CPU core control. MSI actually has some extra settings here, so you can go 1+1 mode, 2+0, 3+0, 2+2, 4+0, 3+3. So most motherboards would only offer the 1+1, 2+2, and 3+3 modes. I'm not sure that the +0 modes actually work. They could, but yeah, I've not tested them, but in theory, they would just disable an entire CCX. So you can run, like, you know, with the 3700X, I have two CCXs in the CCD. So I could run one CCX instead. yeah, it could be useful for, you know, pushing single core, or like, well, you might find that if you're running like benchmarks that are limited to 4 threads, then, you know, something like the 2+2 mode or the 4+0 mode might be actually really beneficial for those kinds of workloads. Next, we have SMT control, so you can disable and enable the simultaneous multi-threading. There are certain workloads where disabling simultaneous multi-threading does lead to performance increases that kind of depend on how much the workload like messes with the memory controller. Because typically the thing about simultaneous multi-threading is like everybody's always like, ooh, more threads, it's great, you get more multi-threaded performance. Yeah, that's true as long as all of your threads don't try to use the same resources at the same time, in which case they just end up fighting each other for resources and actually slow down. But most workloads don't behave like, at least most normal workloads don't behave like that. There are some specialized workloads where disabling SMT is definitely beneficial, but for most people, it would be best to just leave that on auto. Though I guess there's an argument to be made if you have a 3900X or a 3950X, where it's just like you have so many real cores that SMT kind of doesn't, like, you know, unless you're actually using your system for like rendering or something. Like if I was doing like a gaming build with a 3900X, I might actually run it without the SMT. Just because it has so many damn cores to start with, and then you unload the, you know, you reduce the overhead that SMT introduces, which normally is really low. It's like 1 or 2% single-threaded performance that it costs you. But yeah, it's just like when you have, you know, when you have a bunch of unused, like the other thing is if you have SMT off, you can also hit higher overclocks. So that's kind of the thing, is just like, but for most people, it probably just makes sense to leave that auto. Because I assume if you're buying a 3900X, you actually want to make use of the 12 cores and 24 threads. Unless you have a workload which very specifically needs 12 cores and not 24 threads, right? Like, so anyway, you know, so that's a kind of situational setting. In benchmarking, there's definitely uses for it, and I have heard of uses for it outside of that, but for most people, just leave it auto. Anyway, next we have CTDP limit control. So you can, this is basically, so how you have the Precision Boost Overdrive like eco mode here, right? You can restrict the CPU to run 45 watts. Well, you can do that through here as well. So if you want to, you can set the CPU to only run on 35 watts. Or actually, it doesn't go below, there's a restrictor on it. Of course there is. So yeah, it doesn't go below 45 watts. I assume that's that's probably a limit of the, what's it called? Of the I/O die. So, yeah. Anyway, so you can reduce the CPU power limit with that. Then there's a package power limit, which you can use to also adjust the power limits of the CPU. I'm not sure why, like, to me it seems kind of redundant that these two exist, but, I mean, you could run them at both at 1,000 watts, right? If you're doing, like, PBO or something. And if you're doing manual overclocking, both of them are completely irrelevant, because in manual overclocking mode, Ryzen completely just throws out all of the power saving stuff. Just, it gets ignored. So anyway, that's that. You can also disable temperature monitoring, which, I mean, you know, if just adjusting your temperature limit to 255 degrees Celsius isn't high enough, I guess you can try disable the temperature monitoring. Oh no, that's for the post LEDs. Okay, cool. Well, that's what I get for not reading options. Anyway, I don't know why. Oh, I guess maybe if you don't want your system to have the postcode running while the system's running, but this is a really useful function in my opinion, to have the postcode display temperatures while the system is running, because then you don't have to open any monitoring software to at least get a rough idea of what temperature the CPU is at. You know, and the thing is, monitoring software, if you're benchmarking, translates into overhead. So, yeah, it costs you points. So this is a really nice function in my opinion, where it's like, yeah, I can just benchmark in peace without worrying about having hardware info open for one run to check if I'm thermal throttling, and then having to close hardware info so that you can actually do your run, get your score, and then post it, right? Like, nah, you just look at the postcode while it's running. Anyway, so we're just going to set everything right back to auto here, because, yeah, I just want to reset everything as I go. So yeah, that's the advanced CPU configuration. I'm a big fan of MSI actually organizing the BIOS like this. This is a lot nicer layout than some of the other BIOSes, where like for some of those settings you'd have to go digging around in the menus for a while. So yeah, I'm a big fan of that. Here you have the game boost function. You can enable it, disable it. You can, in my opinion, you should just ignore it. It doesn't exist. It was never implemented, and it's a stupid freaking gimmick, and everybody knows it. Well, everybody should know it. Anyway, next we have the CPU base clock. So this board has an external clock gen, and that is true for a couple of MSI motherboards. And the advantages to the external clock gen is that you can set some very fun BCLKs, like, well, oh, come on. I wanted to do... There, much better. So, yeah, the problem with this is, of course, BCLK overclocking screws up your PCIe, it screws up your SATA, it screws up basically everything. So there's a very good chance if you do BCLK overclocking, your system's going to be horrifically unstable, and it's going to be very hard to troubleshoot because there's a chance that everything is unstable, right? Because you're overclocking your memory, your CPU, your SATA, your PCIe, and literally everything on the system at the same time. So you can incur stability problems with the RAM, the CPU, the SATA, and the PCIe at the same time. And then you're going to have to troubleshoot them like one at a time, right? So, yeah. The upside to BCLK overclocking is it is basically like... So in my experience, it's basically the only way to go above 1900 megahertz FCLK. Not that that's particularly useful considering the stability concerns, right? The other use for it that might kind of be viable is you can sort of trick the CPU into running higher single core clocks by bumping up the BCLK. It's not super reliable trying to do that because the CPU tends to... Like most of the time, the CPU will actually notice that the BCLK is like not at 100. And it'll just lower the max ratio, and that really sucks. But there are some interesting interactions between the Precision Boost Overdrive system and BCLK overclocking. It's just that those interactions are also very unreliable, and and also like my biggest success with it was like plus 3% more performance, and it was just a nightmare to get there. So it's like... It's 3% more performance worth it for you, especially considering that if you wanted 3% more single-threaded performance, the easier way to get it would be to just disable something like simultaneous multi-threading, which would actually probably free up some TDP and give you more boost as a side effect. Anyway, so yeah, but BCLK overclocking, at least for like competitive benchmarking, is actually really useful because it is great if you're really trying to push the absolute limit of your CPU. And this motherboard has another really cool feature, which is there are 2 physical buttons on it for adjusting the BCLK while the system is running, which I'm a huge fan of. Like, this is freaking awesome. I really like... More motherboards need more silly buttons like this. Not useful for day-to-day users, but I love this kind of functionality on my motherboards. So, because you can do all kinds of silly things with it, like, well, getting high FCL, like getting higher, it's good for taking screenshots of like really high memory clocks. I actually used it for trying to test high FCLK, like higher than 1900 megahertz FCLK, which is how I found out that my CPU really just can't go above 1900. Like I could go to maybe like 1950 and it would kind of run a few seconds worth of Windows and then it would crash. So yeah, anyway, so you can enable that functionality or disable it with right there. And then you have direct OC steps. So basically you can adjust the increment by which the buttons increase your BCLK. So you can go in tenths of a megahertz or 20ths of a megahertz or literally any value that I just went through, right? Up to 1.6 megahertz per button press. So yeah, I think that's a really neat feature for a board like this. It's just not really that useful to most people. Yeah, but I think it's cool. Unfortunately, it's also a feature that's like stuck on a $700 board, so it's just like, Anyway, next we get some clock gen, sort of advanced overclocking features. The idea behind these is that tweaking something like your BCLK amplitude or slew rate, or I don't know what ORT stands for. Yeah, like this basically might increase stability when doing BCLK overclocking. But I've not messed with these, so I'm not sure how much benefit you can expect from them. Also, the other thing is, like, just because you tweak these a bunch doesn't necessarily mean that, like, you'll be able to, Like, there's a good chance if you do a BCLK overclock and you're crashing in like single-threaded workloads because your single-threaded boost is too high, it's not the BCLK being unstable, it's just your boost is too damn high, okay? So if you're trying to use it for that, like, tweaking these features might not actually do anything. These are really more meant for like, maybe if you're pushing memory really hard, or, you know, just for, like, screenshot purposes, or if you're just running really high BCLK, which, yeah, that used to be like a thing that would get benchmarked. It was like, how high could you push the BCLK of some motherboards? But yeah, for X570, that's not really relevant, but it's still nice to see these kinds of settings available on the board. Even if I doubt they'll, like, for 99.999% of users, actually, I should put a few more nines after that point. Percent of users, this is completely useless, but it's a cool feature, right? Like, the thing with the X570 Godlike is it really is a motherboard that sort of sets out, it will do everything. The side effect of that is it's also horrifically expensive, and as a result, it doesn't really make too much sense, in my opinion, because it's like, who actually needs a motherboard that does everything? You probably just need some parts of what the Godlike does. And that kind of, yeah, and then it doesn't make that much sense. Anyway, here we have AXMP, so you can enable, disable XMP profiles. The reason why MSI has it labeled as AXMP is because XMP is technically an Intel standard, but that doesn't really stop the motherboard, like AMD motherboards, from just reading the SPD chip for the XMP portion of the SPD chip and just using it anyway, right? Like, so... yeah, anyway, it's labeled AXMP so that it's like AMD XMP, even though XMP is an Intel standard. And really, like, it's just reading the regular XMP profile. It's really nothing special. DRAM frequency ratios. So, yeah, you can push the memory frequency around. This is standard for all motherboards. Then we get FCLK frequency. This is another motherboard like this. Well, I'm a fan that this is actually present on this page, because on some other motherboards, you'd be digging through menus for this one. So, yeah. Here's your FCLK, goes all the way, well, basically past 1900. It does, like, well, I've not tested a bunch of CPUs, but my 3700X can just about do 1900, and a little bit over that if you push the BCLK. So, and I think my chip is quite good for FCLK frequency, at least judging by what I've seen on the internet. So, you know, there might be some super gold chips that might be able to kind of do 1933, but everything above that you can just straight up forget about. The silicon is incapable of doing that. So, anyway, and normally you'd probably get stuck somewhere between 1800 and 1900. So, yeah, with 1867 probably being like the upper... more common limit. So, and for my chip, like, actually, that's the case, is like, I can technically run benchmarks at 1900, but at 1867 is actually when it's properly stable. At 1900, it tends to spit out random errors. So, anyway, but that's your FCLK adjustment. Then we have UCLK Div 1 mode. So, basically, this is the control for the ratio between your memory controller and your memory clock. This is, like... honestly, I understand why this setting exists. It's because AMD wants to show off, hey, we can run high-speed DDR4 too. Unfortunately, the way this works, it slows down the memory controller to half your memory clock. So you'd gain 0 performance if you're in UCLK equals MCLK divide by 2. So... that's the thing. Best performance, you're going to be looking at UCLK equals MCLK. If you want to show off with high memory frequencies, then you're going to run UCLK equals MCLK, and you're going to get more latency and basically the same amount of performance as somebody running, you know, 3800 megahertz at UCLK equals MCLK. So, yeah, that's kind of the thing. The only reason you need to really adjust this is if you're pushing above 3600 megahertz, the CPU will force the UCLK to MCLK to be, well, I'm not sure if it's for definitely. The thing is, I've been manually setting everything for a while, so it's like I don't actually know for sure what it does on auto. But basically, if you want to make sure that, you know, you're running 3800 megahertz memory, 1900 megahertz UCLK, 1900 megahertz FCLK, you would want to be at UCLK equals MCLK. if you're pushing past, say, 3800 megahertz and you really just want to show off with high memory frequencies, then you'd want to run UCLK equals memclk divided by 2. So, yeah, the thing is there's a great big latency penalty, and you lose a bunch of performance to running that. So I really... Like, I get that it's cool that AMD can now go like, look, our memory controller can do 5 gigahertz. And it's like, yeah, except it performs like it was at 3.8 gigahertz. So that's great, isn't it? Anyway, next we have load memory presets. So here we have some pretty extreme overclocking memory profiles. These are actually pretty cool because they do preload a bunch of like they set up a lot of your timings for you. Including things like on-die termination and CAD bus timing configuration. So these are some pretty in-depth profiles and pretty useful because of that, in my opinion. Unfortunately, they are only set up for extreme overclocks and at insane voltages. Like, okay, well, no, 4400 CL14 1.85 volts. That's actually pretty reasonable. But 4000 CL12 at 1.7 is... To me, that's insane. I don't have a single kit of memory that can get anywhere near that. I need to run like 2 volts for 4000 CL12. So, yeah, that's 300 millivolts lower. So, yeah, it's kind of the thing. And that is actually like a proper B-die profile. That's 12, 12, 12, 28. So, yeah, it's not like 12, 21 or something. It's a pretty insane profile. Also, the TRRDs actually aren't that tight for it. Anyway, so, you have these extreme overclocking profiles. They're they might give you a good idea of what kind of timings to aim for, but they probably won't work because of the voltages that they're configured for. Like, well, okay, 3800 CL14 might, but 4000 CL12 is insane. Anyway, next we have memory try it. Here you have a bunch of different memory profiles. Unfortunately, these are, in my opinion, far less useful because let's just pull up a random one. Let's pull the highest one, right? Like 5000, 20, 26, 26, 26, 46. The thing is that profile literally just sets your primaries. So it really doesn't configure anything else for you. And the thing about these is like, you can set, there's not that many primary timings in the first place. So, if you've read anything about RAM overclocking, you should be able to set your primaries yourself. Especially because these are literally just like guess and test settings, right? Where it's like, oh, I wonder if my memory will do 5 gigahertz. And then you F10, save and reset. And it's like, oh, no, it won't. Right? Or it might, you might have a great kit of Micron Rev E. And it'll do it. Or you won't, and it won't do it. So that's kind of that. So I don't really find these that useful because it literally just sets your primaries. So this is a bunch of stuff that you could, like, this is also, like, these are so basic that you can really configure that yourself as far as I'm concerned. Anyway, next we have memory failure retry. So basically, this is disabling the motherboard's bad memory settings recovery functionality. So basically, if you punch in a bunch of memory settings that aren't stable, the motherboard will actually try to, eventually go like, hey, we're not posting, and it'll load up and tell you memory overclocking failed. And you can disable that functionality. I don't know why you do that, because that sounds like a great way to put yourself into a clear CMOS situation. But yeah, you can disable that. I still haven't figured out why you'd ever want to do that, because that is one of my favorite features on... Like, if a motherboard has a good auto recovery functionality where it's capable of, like, telling you, hey, you screwed up your memory settings, there's been a soft reboot to deal with that. A soft reset to deal with that. I'm a big fan of that when that works properly, because that can save you a lot of time and, not saving a bunch of profiles all the damn time, because I'm really bad about keeping track of memory, saving BIOS profiles, that kind of thing. So... yeah, this is a functionality that, I guess there might be some scenario where you're running memory settings that are just really hard to get to post and the function, trips too early. But, well, those are not memory settings I'd be very interested in running anyway. So it's obvious the disable option is evidently not there for me. Anyway, with that out of the way, let's get into the advanced DRAM configuration. So here we have all of our timings, right? You saw them before. All of the timings. Secondary, so primaries, which MSI calls main timings. Then we have the sub timings, which I call secondaries, because all of like the turnaround timings are technically still subtimings, right? They're below like they're the next set of time, like another set of subtimings. Anyway, normally I'd call these tertiaries, but these are called turnaround by MSI because it's like read to read, same channel something. Oh, long, and same channel, same DIM, different DIM. Right, so the RDRD is just like read to read delay, like the delay between like back to back read operations, back to back write operations, read to write, read to read, write to read, right? So, and yeah, so it's for turnaround. I think there's a BIOS that calls them back to back timings as well. Anyway, I just call them tertiaries because they're like the third group of memory timings in most BIOSes anyway, most BIOSes. So it's kind of that. Next, we have miscellaneous items where we get our gear down mode or power down enable. So gear down mode, it's a nice little stability booster at the cost of a bunch of latency, which I think you can actually, yeah, MSI has gear down mode enable up here. So actually, if you want to run 1T gear down mode, you actually just want to select straight up gear down mode. And if you want to run straight 1T, then you just set 1T, I think. Though I do believe that, yeah, so MSI does have it set up like that. That's a bit confusing. But hey, they gray it out for you, so you can't really screw yourself over with like enabling 1T and then enabling gear down mode, right? So, yeah. Yeah, gear down mode. My personal experience is that gear down mode is faster than 2T, while more stable than 1T. So 2T is obviously, well, 2T can sometimes be more stable than gear down mode, but generally gear down mode is plenty stable for 90% of, like, well, I usually just do gear down mode. I don't normally run 2T at all. I've not had a reason to run straight 2T yet. 1T is a, if you're really pushing for the absolute limit of performance, you want to go for 1T. And with Ryzen's memory controller, 1T tends to work, like 3rd gen memory controller, 1T tends to work a lot of the time. So that's that's pretty cool. Anyway, so that's one thing to keep in mind here is just like, yeah, you can enable gear down mode down here, but you can also enable it up by the command, right? Next, we have power down enable. So this is basically power savings for DDR. You should, like, if you disable it, that tends to be a stability boost. I think it helps with crashes on, like, recovering from sleep and that kind of thing. I personally just disable it. I don't actually have sleep enabled on any of my systems, and it's not really something I test. But yeah, disabling it gives you a bit of a stability boost. Having it enabled can cause stability issues. So yeah. Anyway, we'll put that back to the auto. Then we have bank group swap, which you can enable or disable, and then you have bank group swap alternative, which you can enable or disable. So these two. They don't do anything to stability, but they can change memory performance but I'm not sure like what the distinction was for them with like synthetics versus real workloads. So it's kind of the thing. But like if you're benchmarking, it would make sense to fiddle with those. If you're just running, well, if you're just doing a daily setup, I honestly wouldn't bother with them because I don't bother with them ever, to be completely honest. But they do affect performance. A little bit, but which kind of, that's the thing with all of the memory settings is like, yeah, you can tweak some of these to an extreme degree, and then the performance impact in 90% of like, actually, yeah, in most workloads is going to be a little bit because memory, especially with Ryzen 3rd Gen where you just have that huge blob of L3 cache, it's just like the impact of the memory is a little bit for most things. So yeah, the biggest boost you'll see is cranking up the FCLK, which is really why you see a lot of people like, well, why optimally you'd actually want like a 3600 megahertz memory kit, just so that you can run 1800 FCLK at 1-to-1 with the UCLK. Anyway, so we have these settings down here. Proc ODT, so on-die termination for the processor. Tweaking this, it's motherboard specific, it's memory specific. With Ryzen 3rd Gen, my experience so far has been that you really end up kind of running settings below 53.3 ohms. Like I've had memory overclocks where they stabilize at like 36.9 or 48 ohms. So that's kind of the thing. So you're going to be looking into the low end of that range. And yeah, it's basically a stability booster for your memory overclocking, and it actually has a lot of impact at higher frequencies. If you're pushing lower timings, like, you know, if you have a set of timings and it's not quite stable, playing with the proc ODT can actually often stabilize it. So this is a very important setting. Unfortunately, it's also like there's no, you know, this setting is always the best for everything. It really depends on like what memory sticks you're running, what memory ICs are on those memory sticks, how many memory sticks you're running, what motherboard you're running. Your CPU might also play a role to some extent. So yeah, that's kind of the thing. But that's your proc ODT setting. Then we have termination for write, nominal termination, park termination. These I normally just leave on auto. They're similar, like they have similar effects as your proc ODT setting. They can make a big difference in terms of maximum frequency, maximum best timings you can run. But my experience has been that if you leave them on auto, they tend to configure themselves just fine. I've not really, like on Intel, I have actually been in scenarios where I had to manually tune them to get certain memory configurations to work to my expectations. But on Ryzen, I've not really seen a reason to do that yet. But yeah, if you want to pour more time into your memory settings, then here's 3 more, you know, 3 more to play with. Luckily, a lot of these are kind of like, if you set them wrong, it won't post. So that's kind of the good thing. They're pretty, you know, they're pretty binary. It either works or it doesn't. So that's the good side to those. But yeah, they're, you know, just more termination settings right there. Then we get CAD bus timing configuration. Also, these are, so this is processor side. This is actually on the DIMMs themselves, this termination setting here. Anyway, next we have CAD bus timing configuration. I actually don't know what these do, so yeah, I'm very sorry, but these exist. You can tweak them. This is where they're located. I just don't know what they do. And then below that we get even, okay, so these I do actually, well, I don't actually know specifically what they do. But they do change, like they do affect your overclock, like your stability. The default setting for all of these is 24 ohms, so that's what your motherboard will default it to if it's auto. And you will find that tweaking these up and down a little bit can sometimes stabilize certain memory settings. In fact, in some scenarios, you will find that actually just setting them correctly will give you a bunch of extra frequency range. They kind of behave like the termination settings as well in that sense. Yeah, normally, you know, I play around with like CLK drive strength and the address command drive strength, not these two. These two you can probably leave on auto 99% of the time, right? So that's kind of that. But that's your memory settings. So it's that. And then we have these. These are extras. I've not seen these on, I think, any other AM4 motherboard yet. So these are new to me completely. I have no idea what they do, but well, okay, no idea. But these are like more memory controller configuration stuff. It's just that I don't know what kind of effects they have or really what parts of the memory controller they affect, right? So we have some training settings. So these, I would assume disabling these would potentially speed up post times, but would not necessarily, like, would lead to worse stability potentially, and enabling them would extend post times but boost stability. This I straight up have no idea what this is. Then MR6, no idea, and unfortunately with this one also no idea. So yeah, but there's a bunch of extra memory controller settings, so, and like, I really wonder what these do. Like, those could be very, like, yeah, but I currently don't know what they do, but they do exist, and the point of these videos is kind of to show all of the settings that are available on the motherboard as well, because sometimes, like, I actually use these videos to reference if a certain setting was present on a motherboard, or what that setting was called, if I can't remember what they named it. So, anyway, next we get into the voltage section of the overclocking menu. I mean, well, yeah, overclocking list, I guess. Anyway, here we start with the digital all power. So these are VRM configuration settings. So we've got load line calibration. There's mode 1, 2, 3. So contrary to this lovely graph over here, mode 1 is actually flat. It doesn't give you voltage boost unless you're measuring on the back of the socket. If you measure on the back of the socket, mode 1 gives you voltage boost. but that's because the socket has resistance, and if you actually measured the voltage at the CPU core proper, mode 1 is flat. Now, there's a good, like, you still shouldn't run at mode 1 LLC because, like, the voltage regulators don't like that. Let's just put it that way. I don't really want to get into the reasons of why you would actually not want to run a completely flat load line. Anyway, I would recommend if you are going to do static overclocking on Ryzen 3rd Gen, which I think is a completely lost cause, but, you know, suit yourself. Admittedly, well, if you're doing extreme overclocking, in which case you're going to just want to test the load line yourself. But if you are going to be doing static overclocking ambient, you should really be using like mode 3 or 4, maybe even 5. Because those have like 3 has a little bit of droop to it. It's not too much, and it just helps the voltage regulator deal with transients. So that's kind of the thing. Yeah, and we do have a lot of load line calibration settings from MSI, so that's kind of neat that they have a lot of, well, a good amount of granularity to it, because some other boards, they, you know, you get load line steps where it's like, okay, this is not enough droop, this is too much droop, and then the next step up from that is, okay, this is not enough droop. Right, so that's kind of the thing. Anyway, next we have over voltage protection. I would honestly just max that out if you're actually running this. Then you have under voltage protection. I would also just max that out. Seriously, like, I've actually not seen a single reason to not do that. So, yeah, because a lot of motherboards don't even have over voltage protection at all. It's just not a thing. Then you have overcurrent protection, which you can just max out. I actually don't know why they don't have a disable for the overcurrent protection. I would personally, like, I assume the enhanced is so high overcurrent that it's basically, like, you're never going to hit it. But it's just, like, I don't know. I would prefer if it was just off. Anyway, next we got CPU switching frequency. So the thing, like, basically, so more VRM switching frequency, you can find that it'll improve your CPU overclocking capabilities, but you're trading VRM efficiency for it. So basically, only, like, raise this if you have VRM thermal headroom, right? If your VRM is running really cool, sure, go for it. Raise it as high as it goes. And if your VRM's overheating, then actually you might want to bump it down to get more thermal headroom, because at lower switching frequencies, you have less switching losses and the VRM actually runs cooler. At higher frequencies, you have more switching losses and the VRM runs warmer, but you get better voltage regulation in return. Or at least you can get better voltage regulation. Kind of depends on how the VRM works. So, yeah. How impactful this will be on your overclocking also kind of really depends. But you can also just, like, the thing is with the Godlike, personally, I would actually just run it at like 800 or 800 kilohertz or straight up 1000 kilohertz, because the VRM on this is absolutely insane. On some of the lower end boards, you might actually want to bump this down instead of up. And by lower end, I mean, like, I don't know, X570 Gaming Plus or something like that. You might actually want to run the switching frequency as low as it goes. But on the high-end boards, yeah, if you've got thermal headroom, like, there's no reason not to just push this up. Unless, of course, you find that it really doesn't do anything for your stability, then it's also just, like, there's no reason not to, like, well, yeah, if it doesn't boost your stability, you can bring it back down, right? But there's really no harm in having it higher if you don't have any thermal issues anyway, so that's kind of the thing. Anyway, next we have VRM over temperature. MSI tends to set their over temperature limit really, like, on some motherboards it's too low, and on some motherboards it's just right. And on motherboards where it's just right, it's like 110, like, I think it's at 125 or somewhere around 115. I would personally recommend that you, like, the OTP would be set like 115 degrees, since that's kind of when you run into the situation, because the thing is, the MOSFET's going to handle 115, 125 just fine. That's not a big deal for them. But by the time the MOSFETs hit 125, everything around the MOSFET starts getting really hot and starts exceeding the temperature limits for those components. So I normally go to sort of 115, because if the MOSFETs are at 115, then everything around them is probably somewhere in the 100-degree range, and that's still within tolerance for those components. So yeah, though MSI on some boards has this set to 100, and it's, in my opinion, unnecessarily low. There's not really any harm in doing that. It just means that, you know, if you don't have perfect case airflow, or, I don't know, you're in a really hot climate, then your CPU might throttle because the VRM is getting a bit too hot, which in this case is actually, like, literally a bit too hot, where it's like the temperature limit's just set too low. Anyway, so that's that. Next, we have the load line calibration for CPU NB, which, I mean, I don't care that MSI calls it the North Bridge, but it's not the North Bridge. It's the I/O die or the system on a chip if you're using a second gen or first gen CPU. Basically, this is the power delivery for everything that isn't the CCDs of a third gen CPU, and for the first and second gen CPUs, everything that isn't the... Actually, no, the CCDs do have an FCLK connection, so that'll actually run off of the SoC VRM as well. So basically, everything that isn't a CCX on the CPU, that's going to run off of the SoC VRM. And that's true even for second gen. Like the CCXs run off of vCore, and everything else runs off of SoC. So yeah, and this is a low power rail. So actually here you can run a more flat load line. So like mode 2, 3, 4. I would honestly go with like mode 2 or 3 because really it is a low power rail. It really doesn't put the VRM under that much stress. Yeah, so you have load line for the SoC rail. Then you have overcurrent protection for the SoC rail, which you may as well just max out again. Switching frequency. The SoC rail pulls very little power, so cranking up the switching frequency for this one makes even less, like, you know, is very, very, well, not very little power, but it pulls a lot less power than vCore, and it's much less likely to overheat compared to, say, the vCore VRM. So here's one where, like, maxing out the switching frequency really doesn't matter. Compared to like the vCore might actually care somewhat about what switching frequency you run. SoC really shouldn't in 90% of cases. So, and again, you know, the SoC VRM, it powers your memory controller, it powers the regulator that then creates VDDG, which powers the FCLK, or, well, the Infinity Fabric, which runs at FCLK, which we'll just refer to that as FCLK. So you may find that you'll get better memory overclocking and better FCLK overclocking if you max out the switching frequency on the CPU NB here. So yeah, that's kind of, if you have thermal headroom, again, why the hell not? Running at 1000 kilohertz, not really going to hurt anything. It doesn't, like that, especially not on the Godlike or even like the Ace or the Creation. Those boards still have ridiculously powerful SoC rails. Some of the lower end boards, maybe you'd actually run out of thermal headroom on those. But yeah, like, this is like this one even more so than the vCore. This is one where you can really crank up the switching frequency if you want to, you know, get that extra little edge in memory overclocking. You might also find that it doesn't make a difference, right? Like there's no guarantees. There's a reason why it's a setting, and MSI doesn't just set it to 1000 kilohertz at the factory. It's because they don't actually, like, they're not sure if 1000 kilohertz will actually help you anyway. All right, so you can configure it yourself. Anyway, next we got DRAM phase control. So I don't believe any of the other boards have the DRAM VRM settings, because the Godlike uses a 2-phase digital memory VRM from monolithic power systems, whereas all the other boards I do believe are like a single kind of dumb 8-pin chip doing the memory voltage regulation. So here you can basically, so DRAM phase control, you can set it to optimized, which basically manages how many phases of the memory VRM. There's only 2 of them, so manages how many phases in the memory VRM are running for optimal power efficiency, or you can just disable it and have it running as a 2-phase all the damn time, which is probably going to make very little to no difference in terms of actual heat output from your memory VRM, because memory really doesn't pull that much power in the first place. So personally, I would just leave that disabled. Voltage protection, max that out. Under voltage protection, max that out. Over current protection, max that out. Switching frequency, sure, max that out as well. You might, again, with the switching frequency, you might find that running higher switching frequency will improve your memory overclocking. For motherboards that don't have the switching frequency, well, they're lower end boards. That's why you can't tweak the switching frequency, right? Like, less features, cheaper board. I've, like, the thing is, I've not yet, like, played with the switching frequency feature a ton on this board, so that's something to keep in mind. I've mostly spent most of my time with the X570 Extreme so far in terms of overclocking. And it's not because I I think the Extreme's better. It's just like, it just happened to be set up on my test bench, and I was going through things, and I was like, well, we're just going to run memory kits on that until I get bored of it, or I need to start working on this board. So, yeah, like, that's kind of the thing. Anyway, so I would personally just max that out. Over temperature for the VRM actually starts at a arguably unreasonable temperature. Like where VCore for some reason is limited, normally set to 100 degrees on MSI boards. Yeah, the memory VRM starts at 135. And I assume that's the default limit as well. Now, the memory VRM really shouldn't get that hot in the first place. And actually, if it got to 135, I'd be really concerned. So yeah, I would honestly like actually lock that, like, well, I assume auto is set to 135 anyway, but you know, you can lock it down to 135 if you want to. And it maxes out at 150 degrees Celsius, which, I would not run that. I cannot think of a single good reason to run, the memory VRM at that temperature. Cause the thing is, like, I can't remember if the actual power stages that the memory VR... Wait, is it power stages? I think it's just discrete MOSFETs. I can't remember. If it's a discrete MOSFETs, they'll literally, like, that's the maximum temperature you can run them at internally. So you shouldn't actually have an external temperature limit set to 150 degrees. If there are power stages, then you can set the internal temperature limit to 150 degrees. That's fine. The thing is just like if the power stages are 150 degrees internally, then everything around them is freaking roasting. So, and there's things like, you know, multi-layer ceramic capacitors, which don't really appreciate being run really hot. Polymer capacitors, which appreciate being run really hot even less. Inductors, which they're relatively robust to high temperatures over short periods of time. But if you run them hot enough for long enough, those too can actually degrade, which... but by hot enough, you actually do have to run them at like close to 150 degrees, though. It's not like capacitors will complain if you run them above 105, or well, it depends on what multi-layer ceramics you're looking at. But yeah, inductors, you know, 150 is actually like, that's not 125 to 150 is actually like the inductors don't necessarily appreciate that too much at that point either. So yeah, this one, I would not raise that above 135 if you were going to tweak it, because I do believe at auto it's set to 135. Also, the memory VRM really shouldn't get that hot. Like, RAM doesn't really pull that much power, though admittedly the Godlike does have a great big airflow restrictor right above where the memory VRM is. I wonder if I should test that. Which would be actually kind of hard, because I don't exactly have a ton of high-density memory. Anyway, so we're just going to reset everything in here. Back to auto. But yeah, unfortunately, the downside to all of these lovely VRM settings that MSI gives you is that Ryzen 3rd Gen overclock, like manually overclocking Ryzen 3rd Gen doesn't really go anywhere. So you probably don't want to play with the first settings, because you want to leave the CPU to do its own voltage management if you're relying on PBO. Well, okay, maxing out the various protections, that's fine. The load line calibration I wouldn't play with if you're on PBO. Overcurrent protection, okay, sure, max that out as well. Switching frequency, yeah, it might actually give you more boost. I'm not entirely, like, I've tried it, but didn't really see any benefits myself, but who knows. The CPU might notice that the voltage regulation's a bit better or something and give you a tad more boost in return. Over temperature protection... Again, you know, set it to 115 if you have to. Northbridge load line, like the Northbridge, the NB settings are the ones I would actually like fiddle with, right? Like the load line, tweak that up and down to see how your to improve memory overclocking, overcurrent protection, switching frequency. All of the DRAM settings also useful. The core settings not really that useful. Anyway, next we got core voltage. We have override mode, offset mode, and AMD overclocking mode. So override mode, you literally just, whatever you punch in is whatever you get combined with whatever load line you have set. So, you know, that's kind of, so if we punch in 1.4 volts and then we set a load line that's, say, mode 1, then our SVI2 TFN sensor under full load should read around 1.4 volts. It's not going to be exactly 1.4 volts because there's tolerance in the voltage regulator and the sensors and everything, so you know it's not going to be exactly what you set, but it's going to be close enough. If you have one of the more droopier settings, you'll actually see the voltage come down as the CPU goes under load. Anyway, so we'll set that back to auto. Override mode, so that's override mode, right? Just static voltage. Override mode, I don't believe should not go, won't have low voltage idle, so that's something to watch out for, or at least it shouldn't. Though I have seen boards where somehow they manage to go low voltage idle even in override mode, which is kind of interesting. And you have offset mode. You can set offset to be positive. You can set offset to be negative, and then you can adjust it, right? So we can adjust it in increments of 12.5 millivolts. That's it. Yeah, 12.5 millivolts. And if you're running PBO, you may find that actually setting a negative offset will give you better temperatures. It won't actually give you more boost. On second gen chips, it would give you more boost, but third gen seems to have fixed that. I assume on second gen it was a bug, because otherwise, why did AMD remove that functionality? I liked it. It was like the only way to get more performance out of the stupid boost algorithm, other than BCLK overclocking. Anyway, yeah, so you can offset negative. Positive offsets, I have no idea why you would use them. The CPU tends to run insane voltages on its own. You really don't want to give it more. I did experiment with this. There's no benefit to trying to run a positive offset. I just absolutely not. Negative offsets, you know, you might get you can get lower temperatures if you're pushing PBO. Though you do want to actually check, like, you can also end up unstable, and you do want to monitor your performance, because if you set the, like, I have heard of people where they set a negative offset and then they lose a bunch of performance. I've personally not experienced that, so that's kind of why I'm saying, like, you know, negative offset might actually be a good idea. Then we have AMD overclocking mode. This actually behaves exactly like override mode, except it seems to report the voltage that you set here as the vid value. I have no idea what the benefit to this is supposed to be. Like, I have tried messing with it a little bit. I can't tell why you wouldn't just run override mode. That seems to work just as well as AMD overclocking mode, but hey, yeah, that is an available option. Anyway, next we get to the voltage setting that is actually far more useful, which is the NB SoC voltage. You have override mode and you have offset mode again. I don't see a point to offset the NB SoC voltage. You should really just override it. And let's see if it'll give me the warning. It won't give me the warning. That is very interesting. Will it give me the warning now? No, it won't. Odd. Okay, so CPU NB SoC voltage. So this affects your memory overclocking. It affects your FCLK overclocking. It has a relationship to the VDDG voltage, which is grayed out right now. You'll get access to the VDDG voltage if you tweak your FCLK. If we just set it to any random frequency, will actually do, right? You set a static FCLK frequency and you get access to the VDDG and the VDDP. So VDDP is actually set off of the, is converted down from VDIM. And it's a power rail for the memory controller's physical interface. I've seen no reason to tweak that voltage. I've never bothered to mess with it. I just leave it auto. The CPU seems perfectly good at configuring it on its own. VDDG voltage, tweaking this voltage up and down, you might find will improve your can improve FCLK stability or even FCLK overclocking range. I tried messing with it on my chip. I can boot high FCLK at as low as like 0.85 volts VDDG. So I don't know. My chip might just be really strange. Or I just need to do more testing. But yeah, VDDG, the other special thing about VDDG is it's actually related to your NB SoC voltage. So it's created by a regulator built into the CPU that runs off of the SoC voltage. So if your SoC voltage is not high enough, your VDDG voltage, like if there's not a big enough difference between your VDDG voltage and your SoC voltage, you're not actually going to get the VDDG you set. So if I set 1.1 VDDG and I set SoC to 1.05, I will actually be only getting about 1 volt VDDG, because the minimum difference between VDDG and SoC voltage is 50 millivolts. And, well, this is 50 millivolts higher than SoC voltage, and the regulator inside the CPU is not capable of doing that. So, yeah, if you want to run, say, you know, that kind of VDDG voltage that I set right there, which is actually not recommended at all, well, you can try it, but in my experience, you'll probably max out at, like, you won't really see any benefit going past, like, 1.05 volts. So something like, you know, if you're pushing a third gen, high FCLK, high memory frequency, tight timings, that kind of thing, you'll probably land somewhere around 1.1 volts to 1.05 volts. Also, if you push your SoC voltage too high, you may find that the PCIe 4.0 just drops out or starts being very buggy. So you might start getting random blue screens, that kind of thing. So, and MSI has told me that happens above 1.1 volts. Gigabyte have told me that happens above 1.2 volts. I can't test it myself because I don't have any PCIe 4.0 devices, so, you know, just something to keep in mind. But if you just stick to below 1.1 volts, right, the lower of the two recommendations, you're pretty much guaranteed to be fine. So, Yeah, that's kind of the thing. Is just, you know, I would stop at like 1.1 volts SoC, unless you're one of those people who only has PCIe 3.0 devices, in which case, knock yourself out. Go all the way up to 1.2 volts. You probably won't see any benefit from actually doing that, though. But it is, theoretically, it is safe for the SoC to go all the way up to 1.2 volts. Since it's still manufactured on the 12 nanometer process, it's just that you're really very unlikely to see any gains in terms of memory overclocking or FCLK overclocking, because I have tried that. It makes, for my chip, it makes zero difference. And I doubt there's going to be significant differences towards other chips. And similarly with the VDDG, is just like, you know, 1.05 volts for VDDG tends to max out a lot of chips, so I don't really see a reason why you'd want to push that higher either. I've actually tested all the way up to like 1.25 SoC with like 1.15 VDDG. Literally no difference. Absolutely no difference. Like, you know, I could take those same settings and run them at 1.1, 1.05, and yeah. So anyway, if you are really maxing out the chip, then yeah, you can set something like that and just forget about those for the rest of time. If you're doing static overclocking, CPU 1P8 voltage, or actually maybe even if you're messing around with pushing the VCLK up, tweaking this voltage up to around, say, 1.9 to 1.95 volts might improve your CPU core stability. This voltage is also extremely useful on LN2 if you're on a second gen. I don't know if that holds true for third gen CPUs, but on second gen chips, this voltage was like, you needed a ton of it to get anywhere. But yeah, for third gen, I don't know how much impact it has on LN2. I've not run a third gen on LN2 yet. MSI has this voltage restricted up to a maximum of 2.4 volts, which I think is a little bit low for a second gen CPU. But for third gen chips, yeah, I'm not sure. And if you're not, you know, you'll probably find that this voltage doesn't actually do anything for your stability, so you may as well leave it on auto. Because yeah, it doesn't like, you know, it's mostly if you're trying to push static overclocks. I don't think with BCLK it would really help that much, but it could. It's just, it might help stabilize core overclocks. That's the thing. So yeah, and again, you know, safe up to around 1.95 volts on that one. Then we get DRAM voltage. MSI restricts this all the way up to just 2 volts, which I'm kind of sad about, because this, like, the Godlike's supposed to be a super extreme overclocking motherboard. I would like that to go up to 2.2. Okay, again, you know, it's just like, and I assume they probably do have a engineering sample, like an ES BIOS, yeah, engineering sample BIOS, where it's like it goes up to 2.2 or 2.3 or whatever, but yeah, I can understand why. Like, the thing is, you generally don't see that much gain pushing past 2 volts, so yeah, it's not a big deal, but yeah, for day-to-day usage, you should stick to less than 1.5 volts, which MSI, kindly for us, does highlight in red. Oh no, they highlight everything above 1.45. Cool, so they're a bit more careful with voltage than I am. But yeah, I would stay under 1.5 myself. MSI seems to think that you should stay under 1.45. Not that the motherboard would care. It's mostly for the sake of like your memory or your memory controller. Though in my experience, like 1.5 should be fine. Like, it really should. Honestly, like, just go to 1.5. You can buy memory kits that ship at 1.5. So yeah, that's kind of that. Anyway, so that's the memory voltage. Not really that much to it. Then we have DRAM VPP voltage. This voltage is by default 2.5 volts. In my experience, this voltage does absolutely nothing. MSI has it restricted to a maximum of 3 volts, and you can set it as low as 1.24 volts, which is actually kind of concerning, because if you set this voltage too low, as in lower than your DRAM voltage, you can damage your memory. So yeah, honestly, I would just not touch that voltage. It's supposed to be 2.5 volts by JEDEC spec, which is like, that's how the DDR4 is supposed to operate. So don't mess with it. And I've really not seen, like, I've messed with that voltage in the past where I'd run it from like, I think 2.3 all the way up to 3 volts. Zero benefit, like absolutely zero benefit to messing with it. So I really don't know why you'd actually like, well, I get that, you know, a lot of boards have this voltage available. I've just not seen any reason to actually mess with that voltage. Next, we have DRAM VREF voltage, which is also the termination voltage. At least it should be also the termination voltage, because termination and ref voltage are normally generated by the same regulator. Interestingly, I don't think this is normal for all motherboards to have it per channel. Yeah, I think so. That's pretty cool that they have it per channel. because I don't think most motherboards have that. Or maybe I missed something on some of the other boards. But anyway, so this is supposed to be half your DRAM voltage. Yeah, the BIOS will configure this for you automatically if you leave it on auto. So if you set like 1.5 volts, these will automatically go to 1.75. Now, both of these voltages, you can find that they'll actually improve memory overclocking capabilities if you tweak them up or down a couple, say 100 millivolts. Which is still within sort of the safe range for the adjustment of those. Because again, with these, if you set them too high, dangerous. If you set them too low, also potentially dangerous. But yeah, you can find that they'll help stabilize certain memory overclocks with certain memory chips. Most of the time, you shouldn't have to mess with those. Actually, I generally don't bother messing with those unless I'm like benching, because like, here's the thing. There's so many different memory variables to memory overclocking that you could spend forever tweaking them. Because, for as many rules as there might be, there's always exceptions. And yeah, it's just like, no, the thing is, like, a lot of rules that exist to memory overclocking work until they don't work. So for example, like, VREF should always be half VDIM. I have a bunch of memory where that works at least up until VDIM is equal to 2 volts, at which point you actually need to set VREF below spec so that the memory keeps functioning. So that's kind of the thing with that. But that's a high voltage extreme overclocking scenario, not a day-to-day usage scenario. So that's why for day-to-day usage, I wouldn't really worry about these, though they can have some stability, they can have an impact on your stability, but I wouldn't worry about them too much. You can also tweak the SoC voltage of the chipset and the LDO voltage of the CLDO voltage of the chipset. These might help with stabilizing high BCLK overclocks, but probably you don't have to tweak them at all. And oh my god, this video is long. Anyway, this is less of a walkthrough and more of an overclocking guide. Anyway, next we have memory change detect. So this setting, basically if you change memory sticks, the motherboard will warn you that, hey, you changed memory sticks. So that's it. And you can disable that functionality if you want to go, swap memory kits and test different memory kits at the same settings. You can disable that. Otherwise, you should really just leave that enabled probably. Next, we have CPU specifications. You can just check the spec of your CPU. No big deal. Memory Z, you can check the SPDs of your memory sticks. Bam, bam. Right. CPU features. You can enable, disable C states. IOMMU, which is for something. I don't know. I don't really care. This is the part where I'm just going to be showing, we've now gotten to the part of the BIOS walkthrough where I'm just going to point to settings and go this exists, because there's a lot of settings in the BIOS where it's you might know that you need it, but I don't know what it does because it's just not relevant to anything I do. Next, we have AMD Cool and Quiet. I've not tried messing with this yet. Apparently, it can help with, having it enabled can help with, idle power state management, but yeah, I've not messed with it myself. So I'm just saying that I've heard such said, but, I might have to do a video covering if that actually does anything or not. If there's no video about that not doing anything, then it doesn't do anything because I've not made a video about it. Anyway, NX mode, I have, whatever the help option says for that one, because I don't know what this does. Enable, disable, SVM mode, enable, disable. Defaults to disabled is for virtualization functionality. I don't do virtualization, so I don't actually know what that affects. Now, power supply idle control. So if you have an old PSU, you may find that you need to be on typical current idle. If you have a modern, proper, good power supply, you should be able to run low current idle. You could also just leave this auto. If you have weird instability issues at idle, then maybe you might want to set the typical current idle, right? That's kind of why that setting exists. Anyway, next we have collaborative power and performance control. CPPC. So yeah, this is to help Windows detect which core is supposed to boost the highest. I think that's what that's for. Some kind of weird, strange power management thing. That's how you know I don't care about it. So yeah, and you can enable, disable that, or leave it auto. Anyway, so that covers the entire OC menu. Let's get into the settings. This gets worse, actually. There are so many settings. So you can set your dates and time. You've got DMI information. So all of this lovely information about the manufacturer. Let's get out of there. Then we get advanced settings, PCIe subsystem settings. You can adjust the PCIe generation of every single one of your PCIe slots. You can even reduce the chipset the generation of the PCIe connection to the chipset, which I think is necessary if you're running like tweaking the BCLK, and I think the board does it for you. So yeah, but on some other motherboards, I've not seen this setting, and also on those same other motherboards, I've had zero success with BCLK overclocking, and I suspect it's related to this setting. So, yeah, anyway, so, you know, you can tweak that up and down. You have above 4G memory cryptocurrency mining, enable, disable. So I think this is for people who run, like, those crazy PCIe lane splitters where you have, like, a million GPUs. I have no experience with this, but it exists. I don't know why you'd use this motherboard for mining, though. PCIe E1 lane configuration. So, oh yeah, this is if you want to use an M.2. So, the M.2 expander card that MSI has for the board. So yeah, you can have up to 4 M.2s on, I think, yeah, that's the primary CPU PCIe slot. So, yeah, if you just want a million, you know, like a million M.2s, there's your setting for you. Anyway, next we get ACPI settings. Yeah, so power LED, dual color, blinking. I don't care. We need to get through this. There are so many settings in this BIOS. Okay, we have CPU over temperature alert. You can enable temperature, you can enable OTP. I would just leave that auto. Integrated peripherals. You can disable your LAN controllers. Actually, there should be 2 of them. Why is there only 1? Because there's a 2.5 gig and a 1 gig. So there should be... That's interesting. I wonder if that one's somewhere else. Anyway, LAN option ROM, whatever that does, I don't know. I don't do networking. Network stack, whatever this does. Oh boy, there's more options in that. So yeah, there's the extra options. So there you go. Onboard Wi-Fi module, you can disable the Wi-Fi if you're so inclined. You have SATA configuration. You can enable RAID mode. You can enable hot plug. Yeah, you can disable your audio if you want to. There are actually, like, if you're doing silly BCLK overclocks, doing things like disabling LAN controllers, audio controllers, SATA ports. Well, actually, no, not SATA ports because you can't disable them, but... yeah, like disabling various controllers around the motherboards can help with high BCLK stability. Then we have some USB configuration, XHCI handoff, enable, disable, legacy USB support, can enable, disable auto. So I think it's auto by default, enabled by default. So yeah. Then we have power management. We have ERP ready. You can enable, disable that. It's disabled by default. Restore AC power. Well, restore after AC power loss. So you know, what the system does after AC power is lost and then restored. So, you know, power outage, and after power comes back on, does the system power on again, or does it stay powered off? Or does it go back to the last state it was in? So if it was running, it'll go back to being running. If it wasn't running, it'll stay turned off. So that's that. Next we have system power fault protection. Enables or disables this. Okay, you'll just have to read the help option for that, because I have no idea what that's supposed to do, because I've not seen that setting before. Wait, what's the help field scrolling? So okay, now there's nowhere to scroll in that. Windows OS configuration. So you have CSM, or you can go UEFI, and then we get more options. I hate this. Yeah, so this part of the BIOS is the part where I was I obviously did some prep for the walkthrough, and I was like, oh god, this is so long. Anyway, no thank you. But then you get key management, and yeah, there's like a bunch of security stuff in there. Yeah, so you can mess with all of this stuff. I'm just gonna wait. No. Let's just go back to CSM, because I have a bunch of old GPUs that are not UEFI compatible. Like, I run a bunch of GPUs that aren't UEFI compatible, so that's that. Mostly because I like to mod the BIOSes, and that breaks UEFI support. That's also like that's the other issue. It's just like if I have a modern GPU, there's a good chance the BIOS doesn't support UEFI anyway. Wake up event, so you can enable how your system gets woken up, right, by various things. Anyway, next we get secure erase. I've not tested this functionality, but it should erase your SSD. I know, thank you. And then we get into the AMD overclocking menu, which, like, on other motherboards, this is where you'd find things like PBO, except, you know, and FCLK settings, except MSI has kindly put all of those in the overclocking tab, but let's get through this. So, you can set CPU frequency and voltage, core count control, all that good stuff. There's actually less core control settings here than there are elsewhere. SMT control, I've already explained all of these. DDR, you know, timing configuration, bam, or you can just set the timings like a normal person through the OC tab. DRAM controller settings, command rate, gear down mode, you could set these through the DRAM OC tab. Power down enable, also available in the memory, you know, in the OC tab. CAD bus configuration, also available in the memory OC tab. Actually, we should put that right back on auto. You know, drive strengths, also available through the OC tab. Data bus configuration, manual, bam. Right, there's your termination settings. You can set that through the OC tab. Infinity fabric frequency dividers. Why is there a submenu for literally one setting? Okay, well, the thing is actually the AMD overclocking menu, as far as I know, is actually like the motherboard vendors can't adjust any of the like anything in it. It just kind of exists. So that's why it's laid out so horrifically. Then we have Eco Mode, which gets its own menu. Again, you could set that through the OC tab. Precision Boost Overdrive, you could set through the OC tab. Well, funnily enough, if you set it from here, you bypass sort of the limits that MSI has set. But I'm pretty sure this will actually bug this out if you set it. Yeah, I'm pretty sure if you set the values too high, it'll actually bug out. So, you know, just caution with this. So. Yeah, that's kind of the thing. So we should set all of those back to 0, put that back to auto. Actually, I wonder if motherboard... No, motherboard doesn't show anything. Then you have the scaler. The scaler works the same way as always. Put it back to auto. Then we have the CPU boost clock override. Yeah, so this is how it's supposed to look. It's supposed to top out at 200 megahertz. Somehow MSI has it going up to 500 megahertz. Like... Either way, it doesn't work, but it's just kind of interesting how MSI somehow managed to get it to go higher than it's supposed to. Anyway, wait, why can't I set it back to auto? Oh, it's just back to 0. Okay, platform thermal throttle. You can set the thermal throttle limit, and this should go back up to, let's see. Okay, it is actually restricted input, so that's fun. But it goes back up to 255, yeah. And, oh, you can't press plus on that, so that's fun. Anyway, we should set that back to auto, right? So all of those are accessible through the OC tab. SoC voltage, you could set your SoC voltage through a freaking... I do believe you have to actually put this in as a hex value. Oh, and you can't punch in pluses. Great. A1. Oh, wait. Is it in millivolts? Or is it like some weird multiple of millivolts? Okay. You know what? Just don't use anything in here. Honestly, like, you're not supposed to use anything in here. It's just like if you're really desperate for something, you can try it from here, but I would strongly recommend you don't go here. Though actually, SoC Uncore OC mode, I don't know if the motherboard automatically takes care of this for you, but this could be, like, basically you can force the SoC to not have power savings and like to not downclock, which could be a stability booster when pushing memory and Infinity Fabric clocks. So, I kind of wish that was available somewhere in the OC tab because I don't remember seeing that. So, but it is present here if you're, you know, that's like so far the one setting that MSI hasn't made easily accessible. Then we have VDDP control, which again, you can just access through the freaking OC tab. Though the nice thing here is it does tell you the default VDDP voltage, which as you can see is 700 millivolts. And VDDG voltage, well, I do believe that's still overridden from the OC tab, isn't it? So it's kind of that. And that covers the entire AMD overclocking section. So, because, it's still overridden from here. So that's why it was showing, 1050 over there. So that was the AMD. Okay, so we've just got through the entire advanced menu. Yay. So here's the boot menu. Here you can, set your full screen, logo, enable, disable, numlock state, info block. I don't know what this does, but it exists. Post beep. You can have the motherboard beep at you when it posts. You know, if you don't find your life annoying enough, you can have the motherboard annoy you too. Boot mode select, UEFI or legacy plus UEFI. I obviously have it legacy plus UEFI because of the GPU situation that I run. Next we have boot order, and yeah, you can choose your boot order. Yay! Okay, so we've gotten through that. UEFI hard disk priorities, right? That's that, hard disk priorities, and that's the end of that. Cool. So that's the boot menu. Next we get the, oh no, there's more security stuff. You can set an administrator password for the BIOS. Trusted computing. You can enable it. I don't have a FTPM module, so yeah, but there's settings for days in here. Why is there so many Okay, no, like, to be fair, if you need these, it's great that they exist, but it's really making this video so long. Chassis intrusion, enable, reset. I actually don't know how this is supposed to work. I don't also really care that much. I guess if you use this, then you know how to use this, right? I guess it's for like system integrators to check if somebody's voided their warranty. Then we get the save and exit menu where you can discard changes and exit, save changes and reboot. You can, you know, just save changes or discard your changes, which we should do. Or you can restore your defaults, which we were on defaults, so if we discard changes, then we go back to defaults. And you also have boot override, so you can tell the motherboard to boot directly. You know, if you want to boot directly into like a USB stick and you don't want to like unplug your hard drive or something, then you can do that from here. So, yeah, that's what you can do from here. And I think I covered everything in the settings tab. Yes! Victory! We can continue. So OC profiles menu, you can save overclocking profiles. Unfortunately, only 6 of them directly onto the board. If you want to save more profiles than that, you're going to have to... Wait, ROM? Load OC... Wait, what? What? Oh, it, like, because, you know, you can load them from here. You can set names. Like so. Actually, what's the name limit? Character limit. Character limit is pretty long. You can clear the profiles as well. What else is there? Yeah, so you can set, you know, you have 6 profiles. You can save profiles to a USB. I don't currently have one plugged in, so that's not going to work. You might also have to have the USB formatted in like FAT32 or something. Again, no USB plugged in, but you can load profiles from a USB stick as well. Next, we have the hardware monitor. And this is my least favorite part of the BIOS because it forces you to use the mouse, which of course is borderline unusable because we're in a BIOS, and BIOSes cannot deal with mice. They're very scared of them, like elephants. Which I think is a myth. But anyway, I don't know anything about elephants, so... Yeah, anyway, so, yeah, you can like, tweak your fan curve with the incredibly... Oh, wait, no, you'd have to first disable the fan smart mode with the very... Like, the worst part is, like... So, in some BIOSes, the mouse is just slow, but there's, like, mouse acceleration in this one. So, this is even worse than what I'm used to. Oh, no, that makes things worse. Okay, I don't know how to use this part of the BIOS. I think... MSI, like, fan control where they force you to use the mouse is just fan control not worth using, which is why when I work with MSI boards, I just don't use the built-in fan control. Oh, there you go. So yeah, if you just have smart fan, you can drag the dots around, you know, with your horribly floaty mouse-accelerated cursor. God, that is awful. Also, like, the lines disappear. Like, just, this is terrible. This should be all controllable with the keyboard. We're in the BIOS, damn it. The BIOS is the land of the keyboard control. Anyway, oh, there's an about button. Should we actually check that out? I'm going to die if we stay in this menu for long enough. Oh, how unuseful. Cool. There's a help button. Does it help me to get the mouse to not suck so much? Oh, no, it doesn't. Okay, you can also tweak, like, your temperature source. So, like what does what controls... Why does that have an animation? Seriously, like, why? It's not bad enough that the mouse is laggy and slow. We need slow animated menus as well, apparently. So, yeah. Okay, so you have some fan hysteresis settings. Damn it. God, I hate that part of the BIOS. I'm also pretty sure that's like the most intent. Like this part of the BIOS probably takes up the most space on the actual like BIOS file, which is just like, yeah, I wouldn't miss this if this was gone. Yeah, step down time. So how quickly the fan ramps down, how quickly the fan ramps up, right? So you'd actually probably want, like, with Ryzen 3rd Gen, you'd probably want to set these pretty slow because Ryzen 3rd Gen tends to be a bit, you know, spiky on the temperatures due to how aggressive and quick the boost system is, and how awful 7 nanometer chips are at shedding heat due to how very dense they are. Well, more like, well, yeah, dense. Like, they're very thermally dense. You have a lot of heat in a very small area, so high thermal density. Anyway, yeah, they give you some fun functions like you can set everything to full speed, all default, or, you know, cancel everything. You can also see the various fan readouts. As you can see, there's no RPMs on any of the fan readouts because, of course, I don't believe in using this god-awful fan control. So I have an external fan controller on this motherboard, which is actually just set to full speed. So I have a pretty high noise tolerance. Plus, this is a test bench, not like a daily system. If this was a daily system, I'd probably have to, like, live through using this god-awful menu. Anyway, we're finally out of that. Next, we get the Board Explorer, which I never understood why this is a thing. But it's a thing. Look, you can look at the I/O of your motherboard in the BIOS instead of just looking at the bloody board. I guess they do have some, like... Oh, yeah, I guess they do tell you, like, which ports are occupied and which aren't and what is and isn't being used, but... The fact that you have, like, yeah, you can't control this with the keyboard again, so the fact that you have to use the mouse with this makes me just, like, I would not touch that with a 10-foot pole. But, you know, videos demand that I make sacrifices, like using this god-awful part of the BIOS. So, why is that highlighted if you're not going to allow me to... Oh, it'll just tell me. Okay, cool. Wait, I can click on the chipset? No, I can't. This doesn't make any bloody sense. Why are some highlights red and why are some highlights white? I'm very confused, MSI. This is screw that. It's too graphical for me. Back to the good old BIOS. So also you can enter flash mode. We're not going to go into flash mode because, well, I don't even have a USB stick plugged in, so it's not going to show us anything. So yeah, that is MSI's BIOS. And you know, if we ignore like, you know, these two bits of the BIOS, and the entire top section, I get, well, most of the top section, not all of it. Like the game boost part, we can just ignore that exists. But yeah, ignoring the, like, you know, that segment of the BIOS, the hardware monitor, the board explorer, I really like MSI's OC menu. I think it's one of the best laid out ones I've seen. So, well, I've not yet seen an Asus X570 BIOS or like an updated X470 BIOS, which I need to get around to. But I kind of expect the Asus BIOS to have a bunch of automated overclocking crap just sort of strewn about the main overclocking menu anyways, so I don't expect it to particularly impress me. But we'll see. I might be wrong about that. But yeah, so far, like, I honestly, like, I can't really think of anything that I'd ask MSI to, like, improve about the actual OC menu. The fan control and the board explorer, just give me keyboard control, damn it. That's pretty much it. For the settings, I mean, oh wait, no, settings. Yeah, the one thing that, you know, I might want to see in the OC menu is that, is the AMD overclock. Yeah, that. This, I'm somewhere in the OC menu, that would be nice to have, I think, maybe, because I have actually used that feature before on other motherboards. I'm not bothered with it on this one. I think it might set it on its own for you, so that's the thing. But other than that, like for one thing, so BCLK overclocking for me on this motherboard actually works, which is a win. Whereas on some of the other ones, like, I've not had success on some of the other ones. Well, yeah, actually, all of the other X570 boards I've tested, I've had no BCLK OC success with. So, yeah, and the actual layout of the, like, I like MSI's BIOS. If we ignore, you know, the horrible parts that require using a mouse and the game boost functionality. So, yeah, that's it for this BIOS walkthrough. Hopefully it covered all of the settings that you wanted to see, and hopefully it was somewhat informative with the settings that I could actually explain, because obviously I only care about things located in the overclocking tab, and And the thing about the overclocking tab is often this one has so many damn settings that it's just like, you know, it's hard. It's hard to know what all of them do. So yeah, anyway, so hopefully that was helpful. And yeah, if you have any comments, questions, suggestions, down in the you can leave them down in the comment section below. There's a good chance that I'll read them and then promptly forget them if they're about settings that I don't care about. So just going to give you a word of warning. If you're like, Buildzoid, this is what SVM mode does, I'll probably read it and then I'll forget it in the next 10 seconds because I don't do virtualization. So it's just like, not important. Anyway, yeah, so that's it for the video. Thanks for watching. Like, share, subscribe, leave any I've already told you to leave comments, questions, suggestions down in I'm not going to repeat myself. You get the idea. But yeah, like, share, subscribe. And if you'd like to support what I do here with AHOC, I do have a Patreon where you can support me directly, or you can buy AHOC merch on Teespring. There's stickers, posters, shirts. There's a new shirt right now. I've revised the design of the Keep Calm and Raise V-Core shirts in black, because I have one of the older black versions. The color contrast on it sucks. So I've redone it with more contrast, as in now it's like orange, black, and white instead of what it was previously supposed to be, which was orange, dark red, and black. Turns out the dark red was very, very close to the actual orange, so it didn't really work. Yeah, so that one's since been fixed. Yeah. Anyway, oh, and I forgot to mention that the board, you know, the X570 Godlike was sent to me by MSI, so thanks to them for sending the board over. And that is it for the video. So thanks for watching, and goodbye.